All right, let's talk about pointers, the bane of everyone's existence. But I promise you it's not that bad. So, pointers or pointer variables, whichever one works for you, they're simply just variables that are designed to hold the memory address of another value. So, let's just start there. To declare a pointer, you have to use the syntax a data type, which it's like integer, double, char, whatever you want, followed by p and then the variable name. Now, this part here is just convention, and you'll see what I'm talking about in a second. So let's just say I have an integer x, and we give that the value of 40. To create a pointer for integer x, we have to do the data type, star p, and then whatever name we want. And then we set that equal to the address of the variable that we want to point to. So this is the variable that we're trying to point to. So we use the address of operator, which is the ampersand sign. And then we say x, because that is the variable that we are pointing to. And this is basically a pointer for integer x. So let's see out these variables to see exactly what we did here. So we will have two statements, standard console out x. And then we'll do it inline. And then let's see out so we see out x here. And we need a L here, syntax error. So we see out x here. Now we're going to see out our pointer after that. Also, I need standard as well. I'm trying to get out of the habit of using namespace because you guys should too. So now we want to see out our pointer. So this is just a simple program. We declared an integer x. Then we declared a pointer to our integer x. Gave it the value address of x. Now let's run this code. So we should get two values here. Okay. So the first statement, cout x, that gave us 40, we know. Cool. We know how that works. The second cout statement, cout the pointer to x. And this returns a memory address. See this hexadecimal value here? This number right here is literally just the address of integer x. I'll link this website in the description here, but this is a really good way to visualize it. Okay, so here I have the code that I created. It's basically the same thing here, minus the cout statements. But from like line 8 to 12 is basically what we have here. So just let's go over it again. We have integer x set to 40, and then we have a pointer px that is assigned to the memory address of the integer x we just made. And that's basically everything that's just going on inside of here. And then over here, we have a little visualizer for the stack. And it basically just tells us what's going on behind the scenes inside of this code. So this red arrow here indicates that this is the next line to be executed. So when I press the next, this will execute this line here on line 3, and it will show us what's going on inside of the computer here. So I hope that makes sense. But basically, this is just the code. And on the right side here, this is just a little visualizer for us to see what's going on inside the code. And let's just spread this out a little bit so we have like a little side-by-side view. Okay, so let's execute this line here. So right now, inside of our main function, we have a variable x and we have a variable px, which is a pointer to an integer, but we don't know what yet because we're only on this line. So let's execute line 3 and let's see what happens. Okay, so we executed line 3. Now, how did our stack change? So inside of our main function, the variable x at this address here is an integer with the value of 40. And that's basically what this line is. Yeah, int x is set equal to 40. So now we're on this line. We didn't execute it yet, but we're about to. So we have a pointer variable px set to the address of x. So when we execute this code, let's see what happens inside of our memory here. Okay. So now px, which is a pointer to an integer, has the value of this address here. So that's basically what pointers are. this pointer holds the value of the address of X. So I hope that visualizer here makes a lot more sense, and I'll just blow this up a little bit more. This is basically what's going on inside of this code. This value here corresponds to this memory address. And we can basically explicitly like see that. So I'll just comment out the pointer stuff. And then instead of couting X, let's just cout the address of X. And let's just see what we get. So we should get this hexadecimal value here, and I'll comment it down here so that you guys can see. So we should get this. Okay, so the value did change. I didn't consider that. Every time you run the code, the memory can change, but we get a hexadecimal value. We get the address of X. And you know what? Let's just put this back in so you guys can actually visualize it even better. So these two statements basically do the same thing, because pointer holds the address of X. And in this case, we're just couting the address of X. And yeah, we get the same memory address. Now, to avoid any confusion, I'm changing this back to just cout at X. But let's say, for example, you want to access the value, right? How do we use our pointer to get the value of integer X? So yeah, I understand that we have a pointer that points to the address, but what if I want the value? Well, that's where the dereference operator comes in. In order to access the value of a pointer, not the address, use the dereference operator. And you can think of this little star whenever you're accessing a pointer. Think of this little star as, hey, go to the address of X and give me the value. And that will basically give us 40. So let's go, before we run this, let's go back to our little visualizer here. Whenever we say star P of X, whenever we cout like star P of X, think of that as like, hey, go to P of X, find the address, go to it, and give me the value that's inside and return that. In this case, 40. So when we cout this, we should get cout X. We know X is 40. Cout P of X, put the reference of it, the dereference of it, and then let's see what we get. 40, 40. So the star dereference operator, that's simply just for accessing the value. Without it, the compiler thinks that you want the address. And sometimes you do. But in this case, we want to cout 40 directly. That's called indirect reference. This is called direct reference. Let me just put comments here. So that was the little intro to pointers. I hope everything up to now makes sense, because now we're going to talk about integers. I mean, we're going to talk about pointing to arrays. Okay, let's create a string array consoles. If you remember my video on arrays, I think I did. We kind of already declared this array. But if you didn't, it's fine. Just a little bit of lore. I don't know why I did cout. So we're going to create a string array called consoles. And then we're going to set this equal to a couple of strings. So we'll do Xbox, because that's the last thing that I played on. PlayStation, because that's the next thing I can think of. And then Dreamcast, because I think it's an underrated console. And then the Wii, because I really like that console. Okay, so we have an array of strings here. Xbox, PlayStation, Dreamcast, Wii. Let's create a pointer to this array. So in order to do that, we have to do standard string, because that is the data type that we're pointing to. The dereference operator, P consoles, we'll call it that because we're pointing to consoles. And then we'll assign it to the address of consoles. Now, if you notice here, we're getting an error. That's because if you remember back to arrays, whenever you pass an array, you're actually passing in the address of the first element in the array. So whenever we're pointing to array, we actually don't need this address of operator. because whenever you call in an array or reference it rather, it's always going to be passed by reference. So we don't need that ampersand sign. It's redundant. If we do this, we're actually just saying the address of, which doesn't make sense in this context. You know what? I put this back. Let's just run this so you guys can see. I think having like a failed compile just kind of etches it in your mind. But yeah, you see it doesn't compile. We get an error here. So that's why, we don't need that. And just to drive the point home, let's just see out consoles to just give you guys an idea of what I'm talking about. So we'll do standard see out. And then we're not going to use the pointer. We're just going to see out consoles, the array. And if you weren't paying attention, you may think this is going to see out all these values. But you'll come to the conclusion that that's not correct when we run this. Okay, so 40, 40. We already discussed these two. But look here. We get an address. That's why we don't need the ampersand sign here, because consoles is already an address. Now, if I see out the pointer to consoles, my pointer, instead of just consoles directly, what do you think will happen? Remember, the pointer is set to consoles. So let's run this. Okay, it gave us the address again. That's because we're couting the pointer, not the dereference. If we want to get the first element of consoles, the value in the first element, we have to use the dereference operator. And that will give us Xbox. Yep. Now, if you want to access a different element or even iterate over this to print out the entire one, you have to use plus. You have to add and then put this in parentheses. And you'll see why in a second, but this basically means take consoles at index 1, 0, 1, and dereference it. So let's print this. Let's run this. So yeah, we get PlayStation because PlayStation is inside of consoles plus 1. Xbox is consoles plus 0. That's why if we don't have anything here, consoles plus 0 is just consoles. That's why we get Xbox. But the reason why I put the parentheses here, whenever I added the plus 1, was because if we don't, we're actually just going to get Xbox. Actually, it doesn't even let me do it. But when we get the address, we would get the Xbox here. And then plus 1, that's adding a string to an integer. And if this was an array of integers here, this element, let's just say this was 1 instead of Xbox, like just ignore the rest of this, just pretend this is an array of integers. This would actually just return 2, like not the next element. So I hope that makes sense. But having the parentheses out here, this is what you want. You don't want no parentheses because you're just gonna mutilate the first element in the array if you have no parentheses. It gets even worse if you just do it like this, because if you remember, this is just the address plus 1. So we're gonna get a hexadecimal value plus 1, which is actually just the next free memory in the array. So yeah, that's basically pointers in a nutshell. I personally wish I could explain this to you guys in a more compact way, but this is honestly such a very complicated topic that I don't think I can shorten this less than 10 minutes. In the next video, I will explain why we need pointers and why they are so important in C++. But for now, just get practice with these with pointers. Like declare some integers, declare some strings, make some pointers for those integers and strings and chars or whatever, and just mess around with them, Declare some arrays, some string arrays, some integers arrays, use pointers, see out, see what happens. And of course, you can go to this website to kind of visualize what's going on in your code. It's called pythontutor.com. I'll just show you guys the homepage. Click on C++, and you can edit the code down here. Just start typing away, and then press this visualize button, and you can go line by line to see what's happening inside of your code.